Hello. Okay, so we did isotopes. Now we're going to move on to ions. And oop, I realize that light up there is shining from my head. Okay. All right, so we just did isotopes. Now let's do ions. It's very similar. Isotopes is where we take or give away electrons. Ions is isotopes is give or take away neutrons. Isotopes would give or take away electrons. So open up the ion practice in Canvas and go ahead and put that into Notability. And we're going to use that piece for this practice. Remember, this is for if you're absent or you need extra help. This video is not to replace instruction. So if you're watching this video because you're absent, you still need to show up for Viking period or before after school tutorials to help you out. Okay, so this is the sheet we're going to be using in a little bit. Before we get started, if you could for right now, scratch that part out. We're going to do it, just not yet. And go to the 4th page. Scratch it out. We're going to do that later on. Just not yet. I just want to get y'all's feet wet right now. And we'll get that part a little bit later. Okay. Go back to blank page. Alright, let's say I have a Bohr model of my favorite element, carbon. The carbon is a 6 up there, a C, 12.011, carbon. Also, refresher of the last video we had, or the nucleide symbols. We have C, the mass, so protons is 6, mass is 12. Alright, let me draw the Bohr model for this guy. I'm sorry, my artwork is not going to be great, but it will be okay. Let's build the little nucleus. And this is really helpful if you actually draw this out on paper, or if you want to use the iPad, but since you're watching the video on here, it'll be kind of hard. Next, I have a nucleus. Let's say we have protons, which are positive, 6, neutrons, 6. So it's just a normal neutral atom. Now let's build some energy levels around it. I use purple this time. I used it last time. Let me get rid of that little color there. Make another one. As you can tell, I'm not the greatest. Oop, no. Uh-oh. There we go. And let's put some electrons on there. So since this is a neutral atom of carbon, we have 6 electrons. 6 protons, 6 electrons. So 1, 2, our first period is now full. Remember the periodic table. First period only has 2 elements. We go and just put that up here to refresh it. Remember, first ring, first period, there's only 1, 2. There's only 2 elements in the first ring. The next energy level, second period, 1, 2, 3, 4. 1, 2, 3, and 4. Alright, now let's get rid of this little edit. We'll save you for later. I don't think we need it though. Alright, so this is a neutral atom of carbon. Now let's say if one day I'd say, you know, carbon, you look cool and all. You have 6 electrons. Can I take one? And then just go yoink and steal that electron away from carbon. Okay, can we do that? We actually can. Is it still carbon? We still have 6 protons. So it's still carbon. But now it has 1, 2, 3, 4, 5 electrons. All right, so let's think of what's the charge. We have 6 protons. So protons, positive 6. Neutrons, they don't count because that's 0. 6 times 0 is whatever. So we're not going to count them. And our electrons are negative. We have 1, 2, 3, 4, 5. So it's plus 6 minus 5. Our overall charge is plus 1. Our net charge is plus 1. We have more protons than electrons. Alright, so that means we have a positive charged atom. So we're going to put carbon, 6 protons. The mass is still 12. Remember, 6 protons, 6 neutrons, still 12. But now we have more protons than electrons. So we have a positive charge. There's more protons. So I'm going to put 1 plus. We have the charge is 1 and it's positive charge. All right? Not too shabby, right? Now, what if we say, I don't want to do it that way. I want to say, Mr. Carbon, you have your 6 electrons. I'm going to be nice and give you an additional 1. Can we do that? Yes, we can. All right, now I haven't told you what this is called yet. We're just looking at it. So now this element, or this atom of carbon, has 6 protons in the middle, and 7 electrons. So our inside has a charge of +6. Our electrons has a negative charge of 7. So it's +6 minus 7. Our overall charge is -1. So we now have carbon. Mass is still 6. Sorry, protons is 6. Mass is 12. Now we have an additional charge. Okay. So now we can say we take away or give away electrons. We have a name for this. When we change the charge, or there's an atom that has a positive or negative, it's not neutral, we call these ions. It means we said, hey, here, have some extra neutrons. Or not neutrons, oh my gosh. I'm sorry, it's kind of late right now. Here's some extra electrons. Or I'm going to take some electrons. Okay? Not too shabby. So let's play with a few of these. I'm going to go to a fresh page. Oh, no. It won't let me do a fresh page that way. And we're going to just play with some positive charges. Let's say we got boron. Boron's mass is, and I do not remember, so let me pull up the periodic table. Come on, move over. All right. It's proton. Ooh, gosh. Protons is 5. Mass is 10.81, so we'll say 11. All right, let's build that Bohr model. And get out of the way, you periodic table. It just won the fight. Oh my gosh. There you go. Move it on over. Let me build a Bohr model here. I have a nucleus. I'm going to have 1. I should have done it purple, but oh well. 2 energy levels. Get rid of those colorings there. And those do not look even, but I think you get the deal. Alright. So in the nucleus we have protons is 5, neutrons is 6, and I realize I put a neutral for protons. There we go, positive. We should have 5 electrons. 1, 2, 3, 4, 5. Alright. Now, we're going to deal with positive charged atoms. So let's take away this electron. Okay? We took it away. What is the overall net charge of this atom? We have 5 protons, 4 electrons. So we have +5 minus 4. Our overall charge is +1. And so I'm going to put a 1 plus up here. Right, we have a name for this. And bear with my drawing. I am not good at drawing. But the name I get for this one, actually I'm not going to say it. I want you to see if you can guess it. Maybe a little thing right here. Do we have an idea what I got yet? Yes, this is going for the name of these guys that are positive charge. See if anybody's guessing what I'm going to call it. Anybody? You may get it if you saw the little posters on the wall all year. A cat ion. We call atoms with a positive charge cations. And here's why. Because they're positive. Get to the positive. Little plus in the positive. So if they have a positive charge, we call them cations. Meow, 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 meow. Yeah, I just did that. So if we have a positive charge atom, it's cation. Cool. All right. So I'm actually going to save this little Bohr model. Oh no, and make another element. Oh, this is not easy. All right. You copy that on over to save us some time. Copy. Actually, we don't have to copy. I just go and erase this. All right, let's pick another atom. Let's say we're going to do with nitrogen. All right, so nitrogen, we have an N. Let's make it a little bigger. All right, and it has a mass of 14, 7 protons. And I want to make a positive 2 charge thing of nitrogen. Well, I can use this Bohr model. I'm going to start in the middle. We have protons, 7 positive protons. Neutrons will be 7. Now, we want an atom that has a positive 2 charge. So we need 2 less electrons than protons. So we have 7 protons, and we need 2 additional positive 2, so we take away 1, 2. All right. So I need 1, 2, 3, 4, 5. Well, let's see. We have 7 positive protons and 5 negative charge electrons. Overall charge is 2 plus. A positive ion or cation. Meow, meow, meow. Easy, easy. See, these aren't going to be hard. I know these terms, like ion, can be very intimidating. They're very easy, as long as you think of cats. Positive. All right, let's go to the next one. Let's talk about negative charge. And this I'm going to ask you, please don't make fun of my artwork, because this is, you thought this cat was bad. Wait till you see about anion. Okay. Let's stay with the same exact nitrogen atom. Let's give it the neutral charge, or neutral's where it's the same on both. 1, 2, 3, 4, 5, 6, 7. This is a neutral charge of nitrogen. All right, just go back and check one more time to make sure we have drawn it right. We have 7 valence electrons. Just find nitrogen. We have a 7A above here. And I realized I said 7. Oh my gosh. We have 1, 2, 3, 4, 5 valence electrons. Nitrogen, 5A. We did it correct. We have 1, 2 rings. 1, 2. Yep, we got nitrogen. We're good. So let me edit you and trash. So we want to make this into a charge, an atom that has a negative charge. So that means we have to have more electrons than protons, because electrons are negative. So we need more electrons. So what I'm going to do is say, hey, nitrogen, I'm going to be nice. You have 2 more. Why 2 more? I just made a number up. We're going to give 2 more right now. You'll be told these. You don't have to really make them. So it'll be fine. So that's nitrogen. Let's see. We have positive, or protons is 7. Our electrons is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. What's plus 7 minus 9? And I just did plus 9. Plus 7 minus 9. Oh my gosh, today's crazy. Plus 7 minus 9 means we have a negative 2, or 2 minus charge. So we previously, when they have a positive charge, we call them cations. Let's see if you can guess what this one's going to be. I'm pretty sure you're not going to guess this one, unless you've looked on those posters on the wall all year, wondering what is that crazy artwork. Start off with a face again. We have a little. guess yet. That little gray here. Anybody guessed it yet? Look at the eyes. If you've been looking at the poster on the wall, you recognize this is an ion. An anion is a negative charged atom. Why is it negative? Well, if that was your hair in the morning, get the little stringly one going this way, you'll be negative too. Like it just, you woke up like, ah! That is an anion. He's very mad. They have more electrons, so they have more earth gift to them. Okay, so negative charged ions are anions. So it's anyone that has extra electrons as to the protons. All right? That's very simple. Let's actually look at some practice. It'll be a lot easier when we hit the practice. Okay, remember we're not doing this piece right now. That's for a different time. So we have a couple of these. We had a couple of these we're going to practice with. I'll not do them all with you, just a few, so you get the idea. So we have a periodic table. Do we have a periodic table? Oh, let's get one. There we go. Move on over. Let's see. Number one, we have 7 protons. Well, that means we got nitrogen here, and 10 electrons. All right, so plus 7 minus 10. Our overall charge is minus 3. Except I don't want to do minus 3. It needs to be 3 minus. Why we write it that way in chemistry, I honestly don't know. It's just the way we do it. All right, what's the element symbol in charge? We have nitrogen, just 7 protons. Nitrogen. Our charge is 3 minus. All right, so this has a negative charge, so that's going to be an anion. Remember, negative is an. All right, so I'm going to put a simple A, anion, negative charge. Let's go to number 2. We have plus 12. We have protons, plus 12 charge. Electrons, minus 10. So we have 10 electrons. Plus 12 minus 10 means our charge is 2 plus. All right, what element do we have? Well, if it's 12, on 12 in the periodic table, magnesium, Mg. Charge is 2 plus. Now we have a positive charge. Meow, meow, meow. Positive. So we have a cation. Our cations are positive. All right. Let's do one more in this section. Number 3. We have 30 protons, 30 electrons, plus 30 minus 30. So our net charge is going to be 0. Our symbol of 30 in the periodic table is zinc, Zn. Our charge is nothing, so we'll leave it blank. And our overall charge is neutral. All right. I'll let you scroll down to the rest of them. Let's go to the next page. For right now, don't worry about this piece yet. We're going to do that in class later on. This part is the same thing. Just a little extra practice. Let's go to the next page over here. I'm going to do 2 of these, and I'll let you do the rest. All right, given the information in the periodic table, complete the following. Well, I have fluorine. I'm doing this one right here. I have fluorine, 9 protons. The mass is 19. The charge is 1 minus. Well, the element fluorine. Did I misspell that? Like flower? I'm not sure. Let's see. No, I did it right. All right, we have 19, not 19, oh my gosh, 9 protons. Now, instead of just writing the number 9, I want you to actually put P plus 9. It helps you. It will help you out later on. The neutrons. Remember, we take our. Let me zoom in here. 19 minus 9 gives us our neutrons, which is 10. Easy, easy. All right. Now, even though it says ion notation, it's still the same thing as nucleotide notation. We're just adding that little charge to it. It's like potato, potato. So many different ways of saying the same thing. All right, let's go to the next one. We have boron. Remember, use your periodic table. The atomic number, notice these are not all the same. So I get protons, neutrons, electrons. Now atomic number, pay attention to what's being asked. I guarantee it, people are going to replace this piece the same thing on all of them. Pay attention to what's being asked. Atomic number is 5. That's the weirdest 5 ever. Our neutrons, take our mass minus the atomic number. 11 minus 5 is 6. Alright, that's it. I know I'm going to just do 2, but let's actually do another one. You pick one at random. Alright, calcium. Alright, so element here is, I can't even spell right now, calcium. The atomic number, which is your protons, 20. Our electrons, ooh, okay. So if we have 20 protons and we have a positive 2 charge, we have more electrons than protons. We have 20 plus 2, we have 22 electrons. So we have 20 protons, we have, oh, no, I just messed that up. Sorry. This is why I thought it was confusing. Alright, so we have 20 protons. We have more protons than electrons because it's positive. So we have 20. So if we have 2 more protons, that means we got to subtract 2 electrons. So we have 18 electrons. Okay, remember we have positive charge, more protons. So we do the opposite. All right, neutrons, 40 minus 20 is 20. All right, so I want you to complete this page here and do some practice. Remember, it's due on Tuesday. This last page, don't touch it yet. We're going to be playing with that a little later on in class, more practice. All right, well, that is all we got. Let's play that video of that little cool snaky thing one more time, and I'll let you go. Remember, if you're watching this video, you probably need to show for vacuum period and tutorials. This is not a replacement for instruction. If you miss class, you still need to show up for those so I can help you out personally, because this video just give you additional assistance. It will not replace it, actually learning it.